I wanted to cover a few things you will have for your CAT exam today, right? I wanted to debrief on everything related to planes, since I think I already had something to entertain both points and lines. Now, when you're dealing with planes, you will only have VP by HP. That is you only have the first quadrant, right? You have the first quadrant. Now, you will have three separate laminas which you can get in planes. You will have the triangular lamina, you'll have the pentagonal lamina, and you'll have the hexagonal lamina. You'd also have a square lamina or a rectangular lamina, but usually you'd have around this much, right? You'd have to construct around this much. And there will only be two cases. One case where the lamina is resting on the edge, and the other case where the lamina is resting on the corner. Now, I will show a small debrief on the construction of these lamina. Before that, we'll just glance at the edge and the corner condition. This is an edge for the hexagon, but if you do this, this will be the corner for a hexagon, right? So that's the corner condition, and that's the edge condition which I showed previously. But for a square, you will have we'll use the polygon itself. For the square, you will have this as the edge condition, and you will have this as the corner condition, right? That's the corner condition, and the previous diagram was the edge condition. For the triangle, I think it's pretty easy. I'm not probably not going to gloss over it, but we'll just show it to you. This is going to be the edge condition, and this is going to be the corner condition for the triangle, right? And I think that's about it. For pentagon, it's similar to the hexagon, both the corner and the edge condition. Now, you can also flip it in the other side. So, for example, let's say that the problem is um, corner condition. I can also draw it this way. It's not going to change anything on how I represent the first diagram, because if it's resting on the corner, and the first diagram I draw like this, in the second diagram where I incline the surface, instead of inclining it this way as I would do standardly, since the corner is in this section, I incline it on this side instead. That's all. So it's not going to change anything. I can rest it however I want, but make sure that the second diagram, you're only inclining the surface on where the corner is. So if the corner was this side, I would incline the line this side, but I'm inclining it in the other way because the corner is in the other direction, right? So now, as we have done on the arrangement of different polygons based on the edge and the corner condition, I just wanted to simply glance at the construction of these polygons. Now the triangular construction, I think, is really simple. You can probably do that on your own. You'll take a line for the triangle, right? And let's say this line, you're trying to construct a 40 mm equilateral triangle. So that's a line. You take the center point of, you take an arc from both the ends of the line. So I'm going to take one arc over here, and I'm going to take another arc from here, right? And as this is both 40, both the arcs should be around 40 mm. Oops. So both the arcs should be around 40 mm. And I can simply join the ends right now, and that will create a triangle with the needed length, right? So the triangle is probably the easiest. The square, it becomes okay. The square is also easy. The edge condition is just normal square, but the corner condition of a square. Now that could be interesting. What I would suggest you to do for the corner condition is first take a straight line, and then you can draw two lines here. Whoops. You can draw two lines here, both of them inclined to 45 degrees, right? That's the first line, and that's inclined to 45. It's like how you did your ISO, but do it on paper. All of this you'll have to do on paper, right? So I recommend you do this for corner condition. If you do not have a set square, if you have a set square, then well, there's no meaning to it. This is 45, this is 45, and this is 90, right? Now what you can do is you'll have to cut arcs after this. I'll take an arc at the corner. I go to the corner, and then I cut an arc at 40 mm there, right? And I do the same thing from here. I cut an arc for 40 mm, and I make sure that these arcs are 40 mm. Now once I've made sure of that, I can simply connect these lines together. I can draw parallel line. I can draw a straight line after that. Oops. First I can draw a parallel line, and then I can draw a straight line here. So that that constructs the corner condition for the square, right? Now the pentagon is pretty easy, and this hexagon is also pretty easy. You can do hexagon by just drawing a circle. So I draw a circle with a certain radius. Let's say the radius is 40. And what I can do is I can depend. So if you're doing the corner, you take the line horizontally. So this will give you the corner condition. If you want to do it, if you want to take the edge condition, you simply draw the line vertically, right? And then you repeat the same thing. So I take here, and I draw arcs right now. All the arcs are 40 mm, and I continue drawing these arcs. Whoops. And once I'm done drawing these arcs, obviously, um, I just have to connect them all together, and I'm done for the most part. Those are my arcs. I can simply connect them with lines, and we will be done, right? That's one, that's two, that's three, that's four, five, and six. So in hexagon is super easy. You just have to do this. And if we had done a vertical line, which is over here, right? If I had done a vertical line, I would simply get the edge condition of the hexagon. So if you do horizontal line, you get the corner condition. Now, pentagon, you can do pentagon in a number of ways. First of all, just a second. Yeah, so as I was saying, you can do pentagon in a number of ways. The first method is easy. Both of the methods are easy. So one way you can draw pentagon is first you draw a straight line, and then you draw another straight line. And what you make sure is you make sure that, now imagine you want a pentagon of 40 mm. So I do 40 mm both these lines. And once I've done that, I basically connect these two lines together, right? So that's the one end of the line, and I connect it to the other end. And I draw an arc from the center till here. I draw an arc, right? So once I'm done with this much, I basically now find the center point. So that's one point, and I draw an arc somewhere here, and that's another point, and I draw an arc somewhere here, right? And I make sure both of these arcs, it doesn't matter what these arcs are, but preferably they should be of the same length. I'll give both these arcs to be around 30, right? That'll be good. It doesn't matter what the length of the arc is because we're only trying to bisect this line. So once I know that I have bisected this line, I get 2 points, right? I get a point there and I get a point here. Now these points will be, this was point 4, this right here is point 4, and that is that's point 4, and that is point 6, right? So those are the 2 points we have. Now we need point 0.5. So you use that for hexagon, you use this for square. We need point 0.5. I need to bisect this line again. How do you do that? You again take equal arcs. Oops. All right, you take one arc from here and you take another arc from here, right? Oops. You take another arc from this point. Now we make sure both of these arcs are equal. I'll make sure both of them are 40. Whoops. Now, you just draw a line from this point here and make sure that the line is straight. That's all. And that point there is what you'll use for a pentagon. And I'll show that in a bit. So imagine you want to draw a pentagon. After you've made the setup, this looks really tedious, but it's really simple when you know what to do, right? And I take an arc. Since I'm doing it for a pentagon, I take it on point 0.5. This point 0.4, point 0.5, and point 0.6. I take it point 0.5 till this, right? And I draw a circle. So I draw a circle of this radius from point 0.5 to the edge. With that radius, I draw a circle. And then I basically start cutting arcs of 40 mm, which is the length of this point and this point, right? I start cutting arcs of that length. So that's my first arc, and I make sure that's 40. Whoops. All right, that's my first arc, and that's 40. Okay, now for the second arc, again, I just continue drawing arcs. It's a lot easier on paper because you just do it in Compass. It's slightly messy when you do it in the software, so I wouldn't worry too much if I were you. And then the third arc from there to there approximately, and that's again 40 mm. And the last arc is from there to approximately there, right? That's this point. You don't have to construct that. You can just connect the lines right now, and that'll give you a pentagon of 4 mm sides, right? So I take a line from this point, I connect it to this point, and I connect it to this point, I connect it to that point. Just make sure that you cut the arcs, connect the arcs properly. So from this point, you join to where the arc cuts there, and from that point again to where the arc cuts, which is there, and again the same thing repeated. Arc cuts there, and you get the arc which is cutting there. So you'll have a pentagon ready with 4 mm sides. This is how we draw a pentagon, right? And with this method, you could also draw hexagon. The only thing you have to do is you'll have to take the radius here, measure that with the compass, and draw a bigger circle, which will be for hexagon. And with this, and you basically cut lines the same way, and you get a hexagon. You can also draw an arc from this. So from this length, I take another point there, and that point is going to be for heptagon, and then octagon. I can do that. I can do them progressively for any polygon using this method, right? With the with the easier method to construct a pentagon will probably be, this is also super easy if you get used to it. Otherwise, you can simply draw a line of your desired length, and then what you can do is you can, of course, imagine this is 40 mm, and what I can do is I can take arcs of 40 mm from both the sides. That's one arc, and I take another arc here. Both of them are 40. Now, once I have taken arcs of 40, what I do is draw, I basically measure 108 degrees and I draw a line. So from this point, this line to this line, it is 108 degrees, right? So I draw a line, and wherever that cuts at the arc, that is the point of my polygon. And the same thing repeated this side. I draw a line from the end of this point straight, and I make sure that the angle is 108 between this point and this point. So once I do that, I get 2 points, and I simply now draw arcs of 40 mm or 4 centimeters to get the last point. So from here, approximately there, oops, and from there I draw another arc. and make sure both of them are 40. And then I connect these points together, which will basically form a pentagon. So that also forms a pentagon. So you can do a pentagon this way, or you can do a pentagon this way. Both of them are easy. I prefer this way because, well, you can use that to construct any polygon. Um, right now, another thing is with the beta problem, right? Now, when you're given, that's my line. When I'm given a line, and imagine I construct anything. Imagine I am constructing a triangle itself, right? So I'll take a triangular lamina, and I'm doing it for the corner condition. So since it's for the corner condition, we'll have it this way around, right? And you just have to make sure that this is vertical. Now I have a triangle. Now if it's in this case, and I basically will incline it this way because the corner is in this side. And when I draw the projections downward, you know that the next triangle which will be formed is going to be slightly smaller than the first triangle. That is, you can notice that the median is much more smaller. This length is going to be the same. If this is like 42, this will also be 42. It won't be 36. It will be 42. But the median length is going to decrease in the second diagram. Now, if the median's length is going to decrease in the second diagram, and they ask you to incline, let's say, an axis or anything which is going to be decreased in the second diagram, they ask you to incline that. That is a beta problem. So, for example, here, if they ask me to incline the edge is not going to be reduced in the second diagram, so it will be a normal problem. If they ask me to incline the median, this median, now we know this median is going to be decreased in the second diagram. But if they ask me to incline the same median, it will be a beta problem where I will first draw a line with that measurement, and then I basically with the angle they have given, because this is true length and they've given the true angle, and I cut it with the apparent apparent length, that is the reduced length. I cut an arc and I get the apparent angle, and then I construct the polygon around that. So whenever, if they're giving an axis which is reduced or a median which is reduced in the second diagram, it is always a beta problem, right?